Okay, folks. Today we're going to be getting into 7.3. This was yesterday, but there were a couple questions after I recorded yesterday, so it's 5B and 15. I'm going to answer these bad boys before we get into the lesson, but we're doing it all at once. So just so you know, if you don't need these, skip ahead for when you see 7.3. All right? Okay, 5B. What is it? Well, simplify each expression. 5B, page 538. Negative 2AB squared over 5A cubed B, 5A cubed B, divided by negative 4A over 15AB. Okay, so we got to flip this bad boy and multiply, and I'm just going to kind of break things up. So negative 2 times A times B times B. Okay, that's this. I'll put the negative 2 in brackets. Could have left the negative outside. Anyway, so now this is 15AB. 15 is 3 times 5. And then A, and then B. All over 5 times A times A times A, because there's 3 of them, 1B. And then here it's negative 4. I wish I would have left the negative on the outside. There I did. Times 4 and A. So now I'm going to start canceling these negatives. Cha-cha, they cancel. 2, is there a 2? Oh, 4. You know what? I should have wrote that 4 differently, sorry. 2, 2 times 2, 2. So 2 and one of those 2's, an A and an A, a B and a B, B, no other B's, 3, no 3's, 5, yes. A, it's another B, so it's 2 A's. All right, what's left over? 3B squared. And A2, so 2A squared. A comma B cannot equal 0. Cool. A and B, those are the only things in the denominator. This flips, but the A comes down, so it's covered. Cool, that's 5B, page 538. And then 15 was desired as well. Simplify. Oh, it's tricky, hey? 1 minus 2 over A over 1 minus 4 over A squared. Oh yeah, okay, so this one's tricky because partially because of the non-permissibles, but also because, you know, it's a fraction. So the non-permissibles is this, but also you have to figure it out kind of for this whole thing. Okay, so I'm just doing that now before I do the solving of it. So first thing I want to do is I want to combine these to make them just kind of one fraction. So I'm going to multiply this 1 by A over A, so they have a common denominator, and then I can combine. So it's going to be A over A minus 2 over A. Now it's going to be A squared down here. So A squared over A squared minus 4 over A squared. So now we have a common denominator. So it's A minus 2 over A minus 2 over A. Isn't this fun? A squared minus 4 over A squared. So that's basically, that's this divided by this, so I'm going to flip this and multiply. So A minus 2 over A times, flipping it, right, A squared over A squared minus 4. Notice A squared minus 4, that's the difference of squares. So I'm going to factor this out just a little bit more. So it's A minus 2 times A times a all over a times a minus 2, a plus 2. So now we look to start canceling. A minus 2, a. So we're left with a over a plus 2. But a, we know a can't equal 0. That's the easiest one. A can't equal 0. But what about this nonsense? Well, figure it out. Do a different color. The way I learned you before. 1 minus 4 over a squared equals 0. Figure it out that way. So if I subtract 1 from both sides, negative 4 over a squared equals negative 1. Divide both by negative, get rid of that sign. I'm going to multiply both sides by a squared to get it out from underneath there. So 4 equals 1 times a squared is just a squared. See where this is going? Take the square root of both sides. So plus or minus 2. Oops, sorry, friends. I don't know what you missed there visually. Subtract 1 from both sides. So this was negative 1. This was negative 4 over a squared. Make them both positive. Multiply or divide both sides by negative 1. Multiply both sides by a squared to get it out from under the fraction. A squared times 1 is a squared. So we have 4 equals a squared. Take the root of both sides. Plus or minus 2 equals a. Which means a cannot equal 0. Nor can it equal plus or minus 2. You can always check these two, hey? Like when a is 0, you know that just throws everything for a loop. But if it was plus or minus 2, if it's 2, 2 squared is 4. 4 divided by 4 is 1. 1 minus 1 is 0. Same if it was negative 2. Oh, I'm pointing again and it's off the screen. If you plug in the 2 or the negative 2 into a squared, either way, negative 2 squared or 2 squared is 4. 4 divided by 4 is 1. 1 minus 1 is 0. There's your answer. Quick check, 15. Yep. All right. I'm going to pause this while I get the lesson ready, and then we'll get rocking and rolling. Okay, friends, here's today's lesson. 7.3, adding and subtracting rational expressions with monomial denominators. Such a fancy, attractive title. Write that down. You did? No, good for you. Adding and subtracting fractions. Same rules apply with a common denominator. If you hung around for question 15 that I just showed a word, then we talked about that a little bit. You need a common denominator to add fractions. Quick little example, like if I say 1 plus a half, I need to put that one, I need to make this a common denominator so I can combine these. So I multiply this by 2 over 2. So that's 2 over 2 plus 1 half. Now it's just 1, so it's 2 over 2. If this was like 16, then I multiply by 2 over 2. Anyway, so 2 plus 1 is 3 over 2. The bottoms don't change. You add the tops, the bottoms don't change. Not doing the CYUs. I'm going to do 6A, 9C, and 11A. And then that's part of your assignment. All right. Okay. Tweak this. Burp, burp, burp. Okay, I think that's pretty good. 6A is on page 554. So 6A, page 554. Simplify, it says 1 over 3A. Simplify, so do the math that's shown, that's asking. 2A over 5A squared. So we need to find a common denominator. It's easiest if we find the lowest common denominator, but really anything is going to work. And I say that because in this case, the lowest common denominator for 3 and 5 will be 15. You can figure that out by just multiplying them together. Sometimes you multiply them together, you're going to get a much bigger number than you need, but it still works, okay, as long as you follow the rules. So the biggest number for these numbers is 15, or sorry, the lowest number is 15. Now for a and a squared, the lowest common denominator is a squared, because both of these go into a squared. So our lowest common denominator is 15a squared. That means that this, we need to multiply this by 5a over 5a, because 5a times 3a is 15a squared. This one, we just have to multiply by 3 over 3, because 3 times 5a squared is 15a squared. Okay, so actually maybe I'll write it like this. 1 over 3a times 5a over 5a plus 2a over 5a squared times 3 over 3. Now, yeah, no, never mind. Okay, so 1 times 5a is 5a. 3a times 5a is 15a squared. Plus 2a times 3 is 6a, all over 15a squared. So we have our common denominator. We can combine these now. By the way, if you're looking at this going, well, why don't I just cancel these? Why don't I just simplify first? Well, that'll just take us back to this. Okay, so 5a plus 6a, that's 11a over 15a squared. Now we can simplify where possible. 11 and 15 have no common factors. You got nothing to cancel there, but you can get rid of this a. A cancels with one of these a's. There's an a left behind. 11 over 15a. I'm going to check, make sure I didn't screw up. I need to do that more regularly because I don't have somebody in class going, that's not what the book says. Oh, it's a good thing I checked too because I forgot to list my non-permissible. By the way, when I say that, someone says that's not what the book says. I'm thankful for that. I'm not being irritated or anything. It's good because otherwise, if people don't say anything, then they have confusion moving forward, and that's not good. Okay, 9C, page. Ooh, that's Baker, hey? Page 556. 9C, so we have 11j minus 7 over 6j squared. And people say, when am I going to use this in real life? K plus 2 over 7k. Okay, this is another situation where lowest common denominator, we're just going to multiply these two together. J and k have nothing in common. 6 and 7 have no common factors. So 42jk. 42, let me just check and make sure that there's nothing lower. 6, 12, 18, 24, 30, 36, 42. That's it. Lowest common denominator is 42jk as a jk. All right. So I'm going to multiply the tops and the bottoms. Do you want me to keep doing it with the colors like this? Maybe? Sure. Yeah. So we got to multiply the top and the bottom of this. Well, I'll just do it here without all the extra steps. So we have 11j minus 7 over 6j times 7k. 7k, oh, I meant to do it in a different color. Oh well. 7k over 7k minus k plus 2 over 7k times, now in this case we've got to multiply by 6j over 6j. 6j over 6j. Okay, so this is this is our kind of addition to give us the lowest common denominator. Now, you see there's some work involved here now. It's not just super simple. 7 times 11 is 77 jk. And 7k minus times negative 7 is negative 49k. All over 6 times 7, 42 jk. Minus 6j times k is 6jk. Plus 6 times 2 is 12j. All over 42 jk. Better room here. Move the camera a little bit. So now we can put these all over common denominator. So notice this negative out in front, that applies to everything here. Okay, so that negative, it's going to, watch, 77 JK minus 49K minus 6JK minus 12J. If this was a negative sign right here, this would change it to a positive. Okay, all over 42JK. And yes, I should have started a new piece of paper. So now we combine what we can on the top. 77JK minus 6JK is going to be 71JK. Sounds like a prime number. 71JK. And then negative 49K. Oh, that's all. Negative 49K and negative 12J. That's all we can do. That's all we can combine. All over 42JK. So now I need to put this on another piece of paper. How can I do this? Because I don't like wasting. I can't. I'm just going to have to do it this way. Oh, can I do this? Can you see how big this stack of scrap paper is? It's massive. I went to the school yesterday and I brought some back. Okay, that's not the only reason I went to school. So now we got to find out what's common. Oh, there isn't. So the thing is, you need, first of all, if you look at a number that's common to 42 and to each of these three. 7 is common in the middle ones here. 6, 2, 3 is common. Nothing here. You need to have something common in everything. So let's say all of these were even, then I could take a 2 out. If maybe I don't need extra paper. If there was a J in each one of these, then I take J away from everything. Or a K in each one of these, I take K away from everything. There's no canceling here. I don't even need the extra space. I just need to say that J, comma K cannot equal 0. Those are our non-permissibles. This is disappointing when nothing cancels. I'm just going to double check my answer. 9C. Oh, it says I'm missing something. What? I'm going to pause this while I look. Okay. I see what I did wrong. First, one of the things to know, 77 turned into 71. Oh yeah, because I canceled. Anyways, here's the big thing. This was J squared in the question. That's where I screwed up. This was supposed to be J squared. So the math is right. The math is right. It's just this would have been a different answer if this was J squared. Crap. So what I would have done, I'm not redoing this because the math is the same. I just wrote the question down wrong. It's irritating. So if this was squared the way it should have been, don't do 9C if you don't want to in the assignment because this is fine. But if this was J squared the way it should have been, then this 7K over 7K, yeah, that would have been fine, but this would have been J squared over here, which obviously would have had ramifications going down. So sorry about that. The math is right. The steps are right. Dummy over here didn't write the question down right. So sorry about that. The math still works out the same way. Still the same steps. Bummer. 11A. Here's where it gets crazy. Page 557. If you think it's crazy, wait till tomorrow's lesson. Tomorrow being Good Friday. Wait till Monday. Here we go. Yeah, it's not even that crazy. Oh, that's right, because we're only doing monomials today. Okay, so 11A says, I'm going to start over here, 6 over 3x minus 2 over 4x plus 3 over 6x. All right, lowest common denominators. 3, 4, and 6, those all go into 12. Remember before I said you can multiply them all, so 3 times 4 is 12, 12 times 6, 72. I could make this the lowest common denominator. Excuse me, 72x. I'm just double checking, making sure none of these are squared. They're not. So I could have made this 72x, and it would still work. It's just harder. I'm going to go with the lowest common denominator, which is 12x. So I have to multiply each of these by whatever I need to ensure 12x. So this, 4 over 4, 3 over 3, 2 over 2. Now in future questions, like I'm looking at question 11D, it's got j and j squared on the bottom, and then just a 2. For those, if you're looking at 11D, page 557, it's got a 3j, 5j squared, and 2. Okay, smart guy, why not put it on the camera? Okay, so your lowest common denominator here, 3, 5, and 2, those all go into 30. Okay, I think that's the lowest, which is what you get when you multiply them all. Anyways, so 30j squared. So this will be 10j over 10j, 6 over 6, 15j squared over 15j squared. So this is a fun one. Have fun with that. That sounds mean. I don't mean to be mean. I didn't sleep good, so I sound like this. Okay. 6 over 3x times, what did I say? It needs to go into 12x, so it's 4 over 4. Minus 2 over 4x, so this is times 3 over 3, because we want to get it to 12. Ah, blue. Did I tell you I didn't sleep well last night? Did I mention that already? Plus 3, nice bracket, over 6x. So this is just going to be 2 over 2. Uh, 6 times 4 is 24. 24 over 12x minus 6 over 12x plus 6 over 12x. Is that right? Oh yeah, because these are each a half. Goodness. You know what I could have done in the beginning? We could have simplified that a bit. So this was a half, like 1 over 2x and 1 over 2x. They would have canceled. Notice they cancel, subtract, and add. But if I'm not skipping any steps, 24, this could have been simplified too, 2 over x. Anyway, 24 minus 6 plus 6 all over 12x. 24 over 12x equals 2 over x, where x can't equal 0, which was what this is right here, because these two cancel. Tricked me. I should have saw that in the beginning, but that's okay. Again, it's like I said before, as long as you kind of follow the rules of math, it'll all work out. You take the long way around or not. There you go. I'm anticipating questions for this assignment, and that's totally fine. But know this, I slept like garbage, so I'm going to post this stuff, and I'm going back to bed, so I might not get to you instantly, but I definitely will. I'm not going to be sleeping for the rest of the day. Peace to you.